This is a review for your compositions and inverses test. Given the graph to the right, find the following: f of 3. So when x is 3, what is our y value? And looking over here, there's not an x value of 3, so this one does not exist. F of negative 1. Well, f of negative 1, this is a composition. We work inside first. F of negative 1 is 2. Then I want to find f of 2. F of 2 is right up here at 6. F of negative 3, again working inside first. F of negative 3 is negative 1. Then I'm looking at f of negative 1. When x is negative 1, the y value is 2. The graph of the inverse. So to be the inverse, we just switch our x and y values. So on this graph, I have the points negative 3, negative 1, negative 1, 2, 1, 3, and 2, 6. And I'm just going to switch those x and y's. So I'd have negative 1, negative 3, 2, negative 1, 3, positive 1, and 6, 2. And graph that. So negative 1, negative 3, 2, negative 1, 3, positive 1, and 6, 2. And I connect them in that same order, and there's my graph of my inverse. And find the inverse at 1. Well, at 1, this is going to be down here at about negative 2. Is this a function? It passes the vertical line test because none of my x values repeat, so yes, this is a function. Looking down at the bottom, given these points, answer the following. Find f of g of 3. So g of 3 is negative 1, and then I'm going to plug that into f. So f of negative 1 is 5. G of f of 5. F of 5, this is my f of x function, is 8. And then I plug g of 8, the x value of 8 gives me a y value of 3. The inverse of f of x, so just switching my x and y values. So I get 4, 2, 5, negative 1, 7, 3, and 8, 5. None of my x values repeat, so it is a function. The inverse of g of x, 2, 5, negative 1, 3, 5, 7, and 3, 8. Again, none of my x values repeat, so yes, it is also a function. If f of x is equal to 2x minus 7 and g of x is equal to x squared minus 3, find g of f of 8. So I'm going to plug 8 into f of x. So f of 8 is equal to 2 times 8 minus 7. 2 times 8 is 16, minus 7 is 9. Then I want to plug that number into g. So g of 9 is equal to 9 squared minus 3. 9 squared is 81, minus 3 is 78. F of g of x. So I'm plugging g of x into f and then simplifying. So that gives me 2 x squared minus 3 minus 7. Distribute my 2, I get 2x squared minus 6 minus 7, and combine f of g of x equals 2x squared minus 13. G of f of x. So I plug f of x into g. So I'm going to have 2x minus 7 squared minus 3. Now I know that term squared means 2x minus 7 times 2x minus 7. 2x times 2x is 4x squared. 2x times negative 7 is a negative 14x. Negative 7 times 2x is negative 14x. Negative 7 times negative 7 is a positive 49. I still have this minus 3 on the end. So g of f of x is equal to 4x squared minus 28x. When I combine those like terms, 49 minus 3 is 46. The inverse of f. Okay, so again, I replace f of x with y. I get y is equal to 2x minus 7. Then I switch my x and y. X is equal to 2y minus 7. Solve for my new y. So I'm going to add 7 to both sides. X plus 7 is equal to 2y. Divide by 2. So replace f with my inverse symbol. So the inverse of f is equal to x plus 7 divided by 2. The inverse of g, x squared minus 3. Okay, this graph would look like this. So to make it invertible, I'm only going to be able to look at the values where x is greater than or equal to 0. So again, same steps, y is equal to x squared minus 3. Then I switch my values, so I get x is equal to y squared minus 3. Then I'm solving for my new y. I'm going to add 3. X plus 3 is equal to y squared. Take the square root. So my inverse is equal to the square root of x plus 3. Now this is my domain of my original. I need to know the range. So the lowest this would go is negative 3. So the range of this one would be y is greater than or equal to 3. That is the domain of my new one. So my negative 3 is my domain of my new graph is x is greater than or equal to negative 3. Using the tables at the right, do the following. G of f of 3. So f of 3 is 5 and g of 5 is 4. F of g of 4. G of 4 is 1. F of 1 is 4. Make a table for the inverse of f. So that's just going to be x and the inverse of x. So 4, 1, 3, 2, 5, 3, 2, 4, 1, 5. Inverse for g, 3, 1, 5, 2, 2, 3, 1, 4, 4, 5. The inverse of 4g, the inverse of g at 4. So that is going this way. I've got my table, so I'm going this way from it, and that is 5. If the inverse of a is 5, then find a. Well, if the inverse of a for function f is 5, that is this value. The only x value that gives me that is 1. So that is going to be the inverse of 1 is equal to 5. A equals 1. Remember, also your test will have a transformation question. Transformation question will be with a square root function, so make sure that you can graph your square root function, move it left, right, up, down, and stretch, compress that function.